In this video, I will demonstrate how Why-Not simplifies the task of reading data from sensors. In the first demo, I will demonstrate a simple example of how to use the PIR motion sensor. The sensor detects any motion in front of it. The motion sensor is fixed on the underside of the board. It occupies the left-hand corner. I'll first start by clicking on the button that reads Check for motion. A message box says that there was no motion that was detected. I'll now move my hand in front of the board and click on the button again. This time the message says that there was a motion in front of the board. So by clicking on this button, we can check if there is any motion in front of the board or not. Let's move on to the next sensor, which is the ultrasound distance range. This sensor is used to measure distance and works like a digital distance scale. This sensor is fixed again on the underside of the board, but on the right hand side opposite to the motion sensor. On the demo app, I will click on the button that says Find Distance. The app shows a message saying that the distance is 134 centimeters. This is because the distance between the board and the nearest obstacle, which in this case is a wall, is around 134 centimeters. Let's check other distances. I'm now holding a brochure as an obstacle at approximately 15 centimeters. When I click on the Get Distance button, the app shows me a message that the distance is 16 centimeters. The ultrasound sensor can be used as a proximity detector or to measure short distances. The next demo is for the LDR. The LDR can be used to measure the intensity of light. The LDR is placed here on the board. The actual LDR is underneath the black tube that you see here. I just use this tube to ensure that I can control the amount of light that the LDR is exposed to. The actual LDR looks like this. So let me put the tube back. On the demo app, I'll click on the button that reads Light Level. The app shows a message box stating that the light level is 2. I'm using one of the Why-Not libraries, which gives me the light level on a scale of 0 to 5. 0 means that there is no light, and 5 means that the light is at the maximum level. In this case, the level of 2 is the ambient light level. I will now cover the tube and then check the light intensity. This time, the application shows a message that the light level is 0, which means that it is very dark. Finally, when I point a flashlight to the LDR and check the light intensity, the message states that the light level is 5, which means that the light is very bright. So let's see the code for all the sensors which we saw in this video. Here again, the entire task is performed in such a short piece of code. For getting the distance, the code is scale.distance. To check whether there is motion around the board, the method is PIR.is_there_motion, or read it as PIR.isThereMotion. And to get the light intensity, it is LDR.intensity. So here again, we are able to read data from the sensors by using simple English-based commands.